Hi, everybody. My name is Carson Zacharias, and I'm presenting to you today the medical application of bisphosphonates. Bisphosphonates are used in the treatment of diseases that are caused by the breakdown of bone in both the veterinary and human medicine industries. And ultimately, what it does and what it's used for is to prevent cellular breakdown. So there are two different types of bisphosphonates: a nitrogenous bisphosphonate that inhibits production of lipids and proteins, and a non-nitrogenous bisphosphonate that inhibits osteoclast activity. And today we will be looking more into non-nitrogenous bisphosphonates. So where the nitrogen would be found and would define whether it's non-nitrogenous or nitrogenous would be in the R group, found here on the right of the the right Lewis diagram on this chart here. And it could be either one, but it's found in a methylene group, which will be one of the R groups, and the other R group is typically going to be an OH anion. So ultimately, in order for bisphosphonates to work, they have to be administered. And this is usually done intravenously or into a synovial joint. And this is done because it gets the bisphosphonate to the bone the quickest. Even though it is more risky, with proper practices, it is done safely. Now, it can be done intramuscularly. However, if it is done that way, then the body has to metabolize it before it can do its work. So bisphosphonates ultimately work because they imitate a pyrophosphate. And the pyrophosphate is the natural occurring molecule that lines the bone, or not line the bone, but that is found in tags diseased bone cells. And that is where osteoclasts will come and pick up and know where to pick up the diseased bone. So a bisphosphonate works because it imitates it. As the pyrophosphate has an oxygen with two phosphate groups, the bisphosphonate has a carbon with two phosphate groups, imitating the pyrophosphate. However, the phosphate groups is where the similarities end. The two R groups is where the dissimilarities are, and that's ultimately where bisphosphonates do their work. And so bisphosphonates line the whole bone structure, and when the osteoclast comes to pick up the pyrophosphate in the diseased bone cell, it picks up a bisphosphonate instead, and that bisphosphonate inhibits that osteoclast's ability to further break down bone. And when this happens, it is now called an osteoclast apoptosis. So, with that happening continuously over and over again in some diseases, um, one bisphosphonate can only hinder one osteoclast. So, with the body creating more osteoclasts to continually break down bone, the you have to continually administer bisphosphonates in order to prevent the breakdown of bone, which this is an issue when the body slowly grows tolerance for bisphosphonates over time. So the way that doctors deal with this issue is they manage it through rest periods, or periods of time that they are not going to administer the drug, to allow the body to get rid of its tolerance for the drug. So usually what they'll do is a rest period followed by administration period and followed by another rest period. And that will lengthen the amount of time that bisphosphonates work in the body. So ultimately, bisphosphonates work to slow down the breakdown of bone, and has proven effective in both the veterinary and human medicine industries, as well as further enhancing the quality of life for patients who suffer from a disease caused by the breakdown of bone or other cellular diseases. Thank you.